Welcome back to another important concept in operating system forget. Today we will be covering page replacement algorithms which are critical when managing virtual memory. When physical memory is full and a new page need to be loaded, the system needed to decide which page to replace. These decisions can have a significant impact on the system's overall performance. Let's see why we need page replacement. In a virtual memory system, we rely on a page replacement when the physical memory means RAM is full and we need to bring in a new page. If the required page is not already in memory, the system triggers a page fault. This forces the system to make a decision. Which page should be removed to make space for the new one? This is where page replacement algorithms comes in. What are the page replacement algorithms? First in, first out. The FIFO algorithm is one of the simplest page replacement algorithms. It replaces the page that has been in memory the longest essentially. The first one that come in the first one to go out. Although it's easy to implement. FIFO is not always efficient because it does not consider how frequently or recently a page has been used. Next is LRU, means least recently used. Least recently used is a smart algorithm than FIFO. It replaces the pages that has been used the last recently. The idea is that pages not used for a long time are less likely to be needed soon. LRU is more efficient than FIFO in many cases, but it requires keep tracking of the user's history of pages, which can increase the overhead. Next, optimal page replacement algorithm. The optimal page replacement algorithm replaces the pages that will not be used for the longest period of time in the future. This provides the lowest possible number of page faults that is purely theoretical because it requires knowledge of future memory access patterns, which is impossible to predict in practice. Now, let's see the comparison between this page replacement algorithm. FIFO. It is the simplest but can to suboptimal performance as it does not consider page usage patterns. Next, LRU. Consider page users history and generally performs better than FIFO but with more overhead. Optimal. The best performance in theory but not feasible in real world scenarios. Choosing the right algorithm depends on the system requirements and available resources. Let's see what is Belad's anomaly. A surprising outcome in page replacement is Belad's anomaly, which occurs in some cases using FIFO instead of reducing page faults when more frames are allocated. The system experiences more page faults. This anomaly is one reason why FIFO is not always preferred. That is for our discussion on page replacement algorithm. These algorithms play a key role in managing virtual memory and optimizing system performance. If you found this explanation helpful, don't forget to like the video to support the channel. Subscribe for more gate preparation content. Drop your questions or topics you want to learn next in the comment below. Thanks for watching. Now that you understand page replacement algorithms, you will prepare for gate questions and virtual memory. Keep learning and practicing this concept. And in the next video, we will tackle advanced memory management techniques like tracing. Until next time, happy studying.